This is the third session of the chapter idea of sets. In first session, we learned some basic concept about the sets, right? The definition of set and what we call that the objects which are existing in one particular sets, right? So set is a collection of well-defined and distinct objects. Set is a collection of well-defined and distinct object. Each and every object which exists in one particular set is called as a element or member of the set. Element or member of the set. And the sets are represented by the capital alphabetical letters, whereas the elements or members of that set is represented with the small alphabetical letters. Right? In next session, in second session, we learned two different methods to represent a sets. That first one is a roster method or tabular form. Second one is roll method or set builder form. In roster method or tabular form, we write all the elements which are existing in one particular set. We write it as a individual elements, or we are making the list of the elements particularly. But in roll method or set builder method, we write one specific definition or specific statement or specific condition or formula that should be satisfied all the elements which are existing in roster method. So these two are the methods we already discussed in the previous classes. In this class, I am going to discuss some exercise question from your exercise 1A, right? See the first question. Which of the following collections are set? Which of the following collections are set? Here, four statements are given. You need to identify what the statement, which statement will form a particular set. What kind of the statement will form a particular set? Right? So the first statement is the collection of the positive integers, the collection of the positive integers that are less than 6. So integers means you already know that the integers is a combination of the positive numbers, negative numbers along with the 0, right? So you need to write the positive integers which is less than 6 means, you can easily write the 6 integers which is less than 6 means 0, 1, 2, 3, 4, 5. So these are the elements or integers which is less than 6. So the first statement will form a set, the collection of the positive integers that are less than 6. So the first given statement will form a particular set. Okay. Next, see the second question. The collection of big cities in India. The collection of big cities in India. So this statement will not form a set because we cannot judge whether the city is big or small. In some criteria, for example, Gadag is also one of the biggest city to compare the other smaller towns or other smaller villages, right? So Dharwad is also one of the biggest city. Belgaum, Mysore, Bangalore, Mangalore, Raichur, Koppala, or next take the other cities existing in another states like Mumbai, Pune. So these are the big cities. We cannot judge the city whether it is big or small. So these statement will not form a set because it doesn't have one specific condition. If they give some specific conditions like the peoples or the population of the city which is more than 10 lakh, that city is considered to be as a big city. Means we can easily judge if a city has more than 10 lakh population. So in this case we are easily identify the which city in India, which city has the population more than 10 lakh. These all cities are considered as a big cities, but they didn't give any information here. They just stated as the collection of the big cities the collection of the big cities of India. So the second statement will not form any set here. Okay. Next, third one, the collection of rich peoples in India. Again, they are not specifying here. They are not given any condition or any terminology. If they are given some specific condition, if a person has more than trillions or more than billions, then that person is considered as a richest person, means we can easily identify. Yes, we have some richest persons also, like Anil Ambani, Mukesh Ambani, Ratan Tata. They are all richest persons. But the same kind, some of the persons also have, some of the politicians also have so much of money, right? So in this case also we cannot form a set, right? So this third question also will not form a set. Next, fourth one, the collection of the integers that are divisible by 3. So collection of the integers that are divisible by 3 means we can easily write the numbers which is divisible by 3, means 3, 6, 9, 12, 15, right? These all numbers, we have infinite numbers which is divisible by 3. What are the multiples of 3? No, all that numbers will easily divisible by 3. So from fourth statement we can form a set. In first main question, the first statement and fourth statement only form a set. First question and fourth question only form a set. Okay, just you need to write the first statement is forming a set and fourth statement is it will form a set. Next, see the second main question. If A is a set of of 1, 2, 3, 4, 5, 6. So these are the 6 elements belonging to the set A. Then which of the following statements are true? Which of the following statements are true? The first one is 6 belongs to A. Second one is 7 belongs to A. 7 does not belongs to A. Third one, 2 belongs to A, 3 belongs to A, and 5 belongs to A. Fourth one, 1, 2, 3 are belongs to A. Fifth one, 6 belongs to A and 8 belongs to A. So these are the given statements. In that you need to identify which statement is true and which one is false. What is that? First, see the elements of set A. What are the elements of set A here? 1, 2, 3, 4, 5, 6. So these 6 elements are belonging to set A. Now you can check whether the elements is belonging in the set or not. Once it is belonging means it is existing in set. That's why the given statement is true. For example, the first one is 6 is belonging to X. 6 belongs to A. 6 belongs to A means 6 is one of the element which is existing in the set A. Therefore, the first one is true. First one is true. Second one, 7 is not belonging. This symbol indicates 7 is not a member of set A because the set A has only 6 elements here. So 7 is not a element of set A means this is also true statement. Right? Because it is not belonging to set A. They are already given here. 7 is not belonging to set A. We cannot have 7. We don't have 7 in the set A. So 7 is not a member of set A. That's why second statement is true. Next, third one. 2 belongs A. Yes, 2 is one of the member of A. 3 belongs A. 3 is also one of the member of A. 5 belongs A. All these 3 numbers are belongs to A. So the given statement is true. Now fourth one, 1, 2, 3. The set of these 3 numbers belongings to A. The individual numbers are belongings to A, but this set is not belonging. The set belongs to A. So the given statement is false. Next one, 6 belongs to A. Yes, 6 belongs to A and 8 belongs to A. 8 is not an element of set A, that's why the given statement is false. Fifth statement is false. 6 is belongs to A, but 8 is not belongs to the set A, that's why the fifth statement is false. Next one, third question. Write each of the following sets by roster method. Write each of the following sets by roster method. Here some statements are given. You need to write that statement in the form of tabular form or to represent the statements in roster method. First one, third main first one, the set of the last 3 months of the year. The set of last 3 months of a year. So the first question, I consider it as a set A. You can take A, B, C, D, whatever it may be to represent a set. Here I am taking A as a set of the last 3 months of a year. Last 3 months of a year. So what are the last 3 months? October, November, December. So these are the last 3 months of a year. Next, the set of the angles of a triangle. The set of the angles of a triangle ABC. If I take the triangle ABC, write the angles of the triangle ABC. So how many angles are there in triangle ABC? 1, 2, 3. 3 angles are there, no? Write the 3 angles in set B. Angle A, angle B and angle C. These 3 are the angles existing in triangle ABC. You can also write angle ABC, BAC and ACB. Simply we are representing 3 angles as angle A, B and C. Third one, the set of even integers between 25 and 35. The set of even integers, that statement I am considering it as a set C. Here you need to write the even numbers which is more than 25 and less than 35, or the even numbers which lies between 25 and 35. So 26 is the first number which is more than 25, 28, 30, 32, 34. So these are the even numbers which is more than 25 and less than 35. Okay, the 3 statements of third main were representing in the tabular form or roster method. Next, fourth question, express each of the following set in the set builder form. Express each of the following sets in the set builder form. First one, the set of the even integers, between 11 and 21. 11 and 21. That set I am considering it as a set A. You can take here A, B, C, D. You can take any capital letter from A to Z to represent a set. Okay. So the first one is the set of the even integers between 11 and 21. So x is a set of x is equal to 2n. X is equal to 2n, where n is belongs to natural number. N is belongs to natural number, and n is less than 6. N is less than 6, and which is less than or equal to 10. N is less than or equal to 6, and n is less than or equal to 10. So this is the statement. N is less than or n is less than or equal to 10. You can also write it as, what is that first statement? The set of the even integers between 11 to 21. 11 and 21 means you can write in simple words as the even numbers from 11 to 21. Right? We are representing the given statement in the form of statement or condition. Right? This is the first one. Now see the second question of fourth main. The set of whole numbers that are divisible by 6 and less than less than 48. That set I am considering it as a set B. Here x is the elements of multiples are divisibility, both are same only. If a number is having multiples, means the same multiples are divisible by the same number also, right? So x is equal to 6p, where p is belongs to whole number, p is less than 8. P is less than 8. What is the exact meaning of this condition? What they are given in the statement? The set of the whole numbers that are divisible by 6. Here p is, now p is considering it as a whole number, that p is belongs to whole number, that p is less than 8. It means here I am taking one particular condition, that x is equal to 6p, or you can also take x is equal to 6n also. If I am taking p is equal to 1, means 6 into 1 is 6. If I am taking p is equal to 2, means 6 into 2 is 12. 6 3s are 18. 6 4s are 24. 6 5s are 30. 6 6s are 36. 6 7s are 42. 6 8s are 48. So x is equal to 6p, that p is belongs to whole number. P is belongs to whole number. P is less than 8. It means if I am taking more than 8, means 6 9s are 54. Just see the statement of second question, which is less than 48, means this 54 which is more than 48. 54 is more than 48, right? That's why I am taking here x is equal to 6p, that p is belongs to whole number, p is less than 8. Or you can also write the first 8 multiples of 6. These are the first 8 multiples of 6. Like that also you can write. Next, see the third question. The set of the factors of 30. Factors of 30. So what are the factors of 30 means? Here, what are the factors of 30? 1, 2, 3, 5, 6, 10, right? 15, 30. So these all are numbers divides 30 without leaving any remainder. So in third statement they gave the set of the factors of 30, means x is a factors of 30. So these all are the factors of 30 which divides the 30 without leaving any remainder. Okay, next, see the fifth question. While we are writing any set in the set builder or rule method, you can write in the condition form, or you can represent the set in the statement form, or you can represent with a suitable formula. But that should be satisfied the given all elements. Once we write any condition or any statement, that statement should be satisfying the all element which belongs to the same set. Okay, see the fifth main question. Express each of the following sets in the tabular and set builder form. Here 5 statements are given. That 5 statements you need to represent in the form of tabular and set builder also. It means you need to represent the statement in the form of roster method and rule method. Okay, see the first question in fifth main. The set of positive integers. The set of positive integers. So positive integers means, first write the given statement in roster method. M is a set of positive integers. So what integers means, you already know that the numbers which are having both positive negative along with a 0. Here given the statement, write the positive integers. The set of the positive integers means I am taking from 1, 2, 3, 4, 5. So we can write infinite number of positive integers. Okay, this is the given statement in roster method. The same statement write in rule method. X is equal to or x is belongings to integers. X is belongings to integers, right? X is belongings to integers. Next, see the second statement, or you can also write here, set M is a collection of the positive integers. Okay, next, second question, the set of odd natural numbers, that set I am considering it as a n. You already know that natural odd numbers. What are the natural odd numbers? 1, 3, 5, 7, 9. We can write infinite number of odd natural numbers. So this is the representation of the given statement in roster method. The same statement we are representing in rule method as x is equal to 2n minus 1, where n is belongs to natural number. For example, if I am taking here 0, means, or you can take just 1, because natural numbers are start from 1, no? So 2 ones are 2 minus 1 is 1. So first natural number. If I am taking 2 twos are 4 minus 1 is 3. So second natural odd number. 2 threes are minus 1, 2 threes are 6 minus 1 is 5. So this statement will satisfy the elements which are existing in set n. Okay, next, see the next question, that is third one, the set of the factors of 24. Third one, set P. Write the factors of 24. What are the factors of 24? 1, 2, 3, 4, 6, 8, 12, 24. So these all elements divide 24 without leaving any remainder. That's why these all are considered as factors of 24. Now the same set represent in rule method. X is equal to factors of x is one of the element. That elements are nothing but factors of 24. Next one, see the next question, fourth one, the set of prime factors of 48. So before writing the elements of the set, we need to prime factorize the given number, that is 48. Prime factorize means dividing the given number with the prime numbers only. So 2 is the first prime number, 2 24s are 2 12s are 2 6s are, next 2 3s are 3 1s are, or 3 is one of the prime number, or you can also write 3 1s are like this. Here 1 is not a prime number, 1 is neither a prime nor a composite. Okay, now write the prime factors of 48. That set I am considering it as a set X. So what are the prime factors of 48? We can write the 48 as 2 into 2 into 2 into 3, but here 2 repeats 4 times. Whenever we are going to be represent a set, if elements are members of a set, repeats more than once means we are taking it as a one time only. That's why 2 is the one element and 3 is the another element. So 2 and 3 are the prime factors of 48. Next, the same statement write in roster method. In roster method we write it as a prime factors of 48. Next, fifth one, The set of the natural numbers which are perfect squares and are less than 50. That set I am considering it as a Z. Now you need to write the perfect square numbers which is less than 50. What are the perfect square numbers which is less than 50? 1 is the perfect square, right? 4, 9, next one 16, 25, 36 and 49. So these all are the perfect square numbers which is less than 50. So the given statement we are representing in roster method, the same statement we are representing in rule method. So perfect square numbers, squares less than 50. Either you can write like this, or Z is equal to x square. Z is equal to x square, that x square, or x is equal to n square, that n is equal or less than 7. Because if I am taking 7 as the last number, means 7 square is 49. So I am taking the numbers which is less than 7. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, whereas the 7 square is 49. So x is equal to n square, and n is belongs to the natural number, n is equal or less than 7. Okay. So these are the 5 questions from your 5th main question. Next, see the 6th question. Write the following set in tabular form. Write the following set in tabular form. First one, here some conditions are given. 6th main, in that first one, x is equal to n by n plus 1. That n is belongs to natural number, n is equal or less than 9. Second one, p is equal to 3n plus 1, that n is belongs to whole number, and n is less than or equal to n, sorry, n is greater than or equal to 2, and which is less than or equal to 5. Third one, r is equal to 7r plus 5, which is less than 36, where r is belongs to whole number. Fourth one, x is equal to y plus 3, where y is greater than or equal to 10 and less than or equal to 14, and y is belongs to natural number. Fifth one, p is equal to 7 times of m, where m is belongs to integers, that m is greater than or equal to -1 and less than or equal to 3. Sixth one, x belongs to natural number and x cube which is less than 30. For these all given statements, you need to write the elements in tabular form. See the first statement. What is that first statement? I am considering it as a set A. Statement is x is equal to n divided by n plus 1, that n is belongs to natural number and which is less than or equal to 9. Means here I am substituting n value as 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right? So if I substituting 1, what is that formula? X is equal to n divided by n plus 1 means 1 divided by 1 plus 1 is 2. So first one is 1 divided by 1 plus 1. 1 divided by 1 plus 1 which is equal to 1 divided by 2. Next one, in the place of n value now take it as a 2. 2 divided by 2 plus 1 is 3. So 2 by 3. Next 3 by 4. Next 4 by 5. Next 5 by 6. 6 by 7. 7 by 8. 8 by 9, right? Next one, n value is up to 9, no? So 9 divided by 10. So these are the required elements of the first set. Okay, just we are changing the n value. N is, if n is equal to 1 means n 1 divided by 1 plus 1 is 2, so 1 by 2. If n is equal to 2 means 2 divided by 2, 2 divided by 2 plus 1 is 3. Like this we are writing the whole series of the first set. Next one, second question, set B. Set B, what it says? Set B, set B is a P is equal to 3n plus 1. Given condition, just need to concentrate on that condition. So here P is indicates the elements of the set B. So that P is obtaining by 3n plus 1, obtaining by the formula 3n plus 1, where n is belongs to the natural number and which is equal or which is more than 2 and less than 5. It means I have to take here 2, 3, 4 and 5. For these values, these 5 values, all 4 values you need to substitute in this condition, and what you are getting the result at, no, that are the elements of the set B. For example, 3 2s are 6, 6 plus 1 is 7. Next, 3 3s are, in the place of n, now I am taking as a 3. n is equal to 3 means, if n is equal to 3 means 3 3s are 9, 9 plus 1 is 10. Next, if n is equal to 4 means 3 4s are 12, 12 plus 1 is 13. Next, if n is equal to 5 means 3 5s are 15, 15 plus 1 is 16. So these are the required elements of the given set. Okay, next, see the third question. What it says, third question, R is equal to 7 into R plus 5, which is less than 36, where R is the belongings to whole number. Now take the whole numbers, 0, 1, 2, 3, 4. If I am taking 7 into 0 means 0, 0 plus 5 is 5. So third question, that set I am considering it as a set C. So R value, now R value is 0, 7 into 0 is 0, 0 plus 5 is 5, so 5 is the first element. Next, now R is equal to 1 means 7 ones are 7, 7 plus 5 is 12. Next, if R is equal to 2 means 7 2s are 14, 14 plus 5 is 19. Now R is equal to 3 means 7 3s are 21, 21 plus 5 means 26. 7 4s are 28, 28 plus 5, 28 plus 5 is 33. Next, if I am taking R is equal to 5 means 7 5s are 35, 35 plus 5, that is equal to 40, 40 is more than 36, that's why I am taking here up to 4 only. So these are the required elements for the set CR for the third question. Next, see the fourth question. What is that given statement? Just you need to substitute A value or n value or R value in the required conditions. See the fourth question, x is equal to y plus 3. X is equal to y plus 3. Given condition is x is the elements. X are the elements of set D. X are the elements of set D. That elements we are getting through this formula. What is that given formula? X is equal to y plus 3. That y is more than 10 and less than 14, and y is belonging to the natural number. Natural numbers means here I am taking y only the positive values. So more than 10 means the first number is more than or equal. They gave more than or equal means I am taking from 10. So if y is equal to 10 means just substitute the y value in this equation. What you will get? 10 plus 3 is 13. Y is equal to 11 means 11 plus 3 is 14. Y is equal to 12. 12 plus 3 is 15. Right? Next, y is equal to 13 means 13 plus 3 is 16. Next, y is equal to 14. 14 plus 3 is 17. So they gave one condition, that is y is less than or y is greater than or equal to 10 and which is less than or equal to 14. Okay, here I am taking y value as 10, 11, 12, 13, 14 and we get the elements of set D. So these are the required elements of set D. Next, see the fifth question. What they give the statement, some conditions are given in fifth statement also. P is equal to 7m, where P is equal to 7m, where m is belongings to integer. M is belongings to integer, that m is more than or equal to -1 and less than or equal to 3. Right? So for this statement you need to write the values. First one, they give -1, m value is greater than -1, greater than or equal to -1 and which is less than or equal to 3 means I am taking here m as a -1, m as a 0, m is equal to 1, m is equal to 2, m is equal to 3 because they gave up to 3. Substitute these value in the equation or in the given standard condition. P is equal to 7m. That set I am taking it as a E. So m is equal to 1 means 7 into -1, -7. 7 into 0, 7 into 0 is 0. 7 into 1, 7. 7 2s are 7 2s are, because m value is 2, no? So 7 2s are 14. 7 3s are 21. So these are the required elements of the fifth question. Next, sixth one. X belongs to natural numbers. X belongs to natural numbers where x cube is less than 30. Here, that sixth question I am considering it as a set F. You need to write the cube, perfect cube roots, perfect cube values which is less than 30. So 1 cube is 1, 2 cube is 8, 3 cube is 27. So you need to write the x values. So these are the x values. These are the x values. If I am taking here 1 cube is 1, 2 cube is 8 and 3 cube is 27. So the required values are 1, 2, 3. These three are the elements of sixth question. Okay. Next one. See the seventh question. In seventh question, totally 5 questions are there. I will solve. You need 2 questions. Remaining questions you need to practice. So in these type of questions we will represent in roster method as well as in the rule method, right? See the seventh main question, what it says, that seventh main question, they express the following sets in set builder form. Here they already gave some elements or list of the elements in the particular set. You need to write that some specific conditions or formulas, some statements for that given values or given sets. Seventh main first one, 1, 1 by 2, 1 by 3, 1 by 4. So this is the given question. For this you need to write, for this set you need to represent the same set in set builder form or rule form. The first question, now I am representing in set builder form as x is equal to what they are given here, 1 by n, that n is belongings to the natural number. If I am taking here 1 by 1, next 1 by 2, 1 by 3, right? So this is the required condition for the first question. Next, second one. What are the elements of second question? 3, 6, 9, 12, 15. So when you are observing these numbers, you will get some ideas. These are the multiples of 5. Set B, that means second question are the multiples of 3, 3, 6, 9, 12, 15 are the multiples of 3, less than 15 or less than 18, because we are considering here up to 15 means you need to write here less than 16 or less than 17, or the next multiple is 18. That's why I'm taking it as a less than 18. You can also write less than 16, less than 70. Okay, next, third main question. 0, 4, 8, 12, 16, 24, 28, 32, 36, 40. For this third question, we need to represent the third question in set builder form. So here the C is a set of x is equal to 4n, that n belongs to whole numbers. N belongs to whole numbers because the 4 numbers are start from 0 and n is greater than or equal to 0. N is greater than or equal to 0 and which is less than or equal to 10. This is the statement that satisfied the given elements. Remaining 2 questions are there. Just you need to practice that question, solve that questions. For example, first one, fourth one is 1, 2, 13 and 26. These are the factors of 26, whereas the second one is last question. Fifth one is minus 24, minus 12, 0, 12, 24, 36, 48, 16. So this is the condition requires x is equal to 12 times of n, that n belongs to whole number, right? N belongs to whole number, n is greater than minus 2 and which is less than or equal to 5. So this is the required condition. Just practice that 2 remaining questions, fourth one and fifth one. In the next class we will discuss about the different types of these sets. Until then, take care. Be happy. Have a nice day. Thank you for watching.